This will just be a little walkthrough of how to use the LODSync component inside Unreal Engine with these metahumans to make sure that the LODs pop in and out properly. You'll want to copy these settings over from this video that I talked through over to any future metahumans that you create to deploy on Oculus Quest. Okay, so let's take a look. This is the L_train level. I added a little bit of some kit bashing into here using the Unreal in-editor modeling tools just to put a little placeholder of a train car in here. So here you see we have Angus and we have Wayland and we've got the conductor here. So along with some baked lighting baked into a light map for this environment. So let's take a look at, say, the conductor's blueprint. See if we can get a handle on how LODSync component works. Okay, so here's the conductor's blueprint. If we go into LODSync component, there are 3 sections here that are important to copy over. First is just these 3 numbers, 8, -1, and 0. You can just leave those. I think those are default. The second is this components to sync section. So twirl that open and let's take a look at that and understand how this works. So if you read the comment here, if you highlight components to sync, it's quite misleading and it definitely leaves out some very critical information. So, says components that are flagged as drive are treated as being in priority order, the last component having highest priority. The highest priority visible component will set the LOD for all other components. What it should read is the highest priority visible component labeled drive will set the LOD of all other components. Very important, very important. If no components are visible, then the highest priority non-visible component will set LOD. And again, I think it should say the highest priority non-visible component labeled drive will set the LOD. I'm not 100% sure on that, but I believe that's how it works. So, okay, so what does it actually mean? So what I've done is I've gone through and labeled everything as passive except for the very last one, torso. And I've set that to drive. And now these are not the default orderings of the components, so I've reordered them just by erasing this and typing in a new name there. So you just want to make sure that these names match up to the component names over here. So face matches up with face. If you change this to face 2, you'll probably want to change that to face 2. But you can kind of rearrange the order of these in that way just by hitting delete and typing in the word of what you want to swap it with. But I've rearranged them so it's face, body, legs, feet, hair, eyebrows, eyelashes, fuzz, beard, mustache, and then finally torso. Now, if you wanted to delete some of these, say you decide you never ever want to have a PC VR release and you never want to have these high quality grooms over here, such as beard and fuzz, if you delete those, then you can go over here and then you could find fuzz, say, and you could delete that, I believe. But I've left them in there. They're not shown or rendered anyways on Oculus Quest, so there's no harm in leaving them in, I believe. So I've gone ahead and left them in there in case you guys want to use a PC VR build someday. So importantly, torso is set to drive. So what does that mean? So it means whatever values torso has, whatever LOD values it wants to display at a certain distance, it will attempt to tell everything that's labeled passive, or anything that's labeled drive but is further up the list. So basically try to tell everything else in this list to adopt that same LOD level. Now, if you have, say, body at the top, that you have, or say face at the top, and your face mesh, you've decided that you really want it to be driven down to LOD 0. So you've gone through and you've gone to the custom LOD mapping for, let's see, face, and say you wanted to set all these values all to 0 all throughout. But then on your torso, which is your last component, which is driving all of the other LODs, say on your torso, this value, this value, this value, all these began at a higher LOD, such as LOD3. Well, LOD3 could not drive face to LOD0. Now, in this case, we have it in the reverse, which works just fine. So basically, you want, if you have any components on your mesh that do need to go to a low LOD, such as LOD0, you want to make sure that whatever component is driving all the other LODs, you need to make sure that it also goes all the way down to 0 at some of these distances here. So if we set, for example, torso is driving everything right now. So if we set torso to all just 4 all the way down the list, or everything down to 3 all the way down the list, it would not be able to say drive the feet ever to 2. They would just start off at 3 and all of these 2s would be ignored. So in other words, feet can override things to a higher value than what torso is telling it to do, but it cannot override things to a lower value than what torso is wanting it to do. So that's important to understand, and it is not explained anywhere in these comments or anywhere on the entire internet. So very, very important. It kind of works in a greater than or equal to fashion. So feet can be driven to this value here. It's saying that the LOD at the closest distance of feet, or your shoes mesh, is going to be greater than or equal to, it's going to be greater than or equal to whatever is the greatest value between 0 here and 2, but it cannot drive things lower. So if this torso started off at 3, you could never see a value of 2 actually displayed. You could never hit LOD2 on device for the feet. It would just start off at 3 by default. Okay, so with that kind of in place, let's take a look at all of these custom mappings. One last note is, for some reason, I do also have to list eyebrows and eyelashes as drive. Well, I know eyelashes as drive for some reason. That's the only way you can get the eyelashes to appear. So I don't know why setting that to passive does not work. For some reason, does not. So I think it's probably a glitch or an error in their logic of how LODSync component works, but I'm not certain. So anyway, so really you need to set 3 things to drive, and I would try to stick with this order: face, body, legs, feet, hair, eyebrows, eyelashes, fuzz, beard, mustache, and finally torso. The only exception to that is if you were going to have a character that did not have a torso. So say you had a character that you could remove the clothes or steal the outfit of one of these characters after you had knocked them out. Well, what would happen is if you based everything off a mesh which was set to invisible or wasn't present, and that was the only one set to driving it, and that mesh was not present, so the clothing mesh was not present on the character, or not visible, then as you got closer to the character, none of the LODs would be driven. They would not pop in and out correctly. If you started from far away looking at the character and you came up to the character slowly over time, the character would always forever remain in a very, very poor LOD quality state. So you would just want to make sure whatever you're driving it with, that mesh is set to visible. So in this case, I've just gone ahead and assumed that you guys will always have clothes on all of the characters in the game, but if that's not true, then you'll probably want to rethink the logic and maybe say have the body be what's driving everything, and move body down to the bottom slot here, and then you could move torso to where, say, body is. And then you'd want to set body to drive and torso to follow, or passive, as it is here. And then you'd, of course, want to make sure just body went at least as low as the lowest LOD you want any other component on the character to go. Very important for whatever's driving to at least go as low as that. So, okay. So that's kind of how it works. These settings are very finicky. So I've done a lot of work to make sure that they work at all distance levels, so that the head, or as it's called, face mesh, actually aligns with the shoulder neck seam here of the body at all LODs. So these look kind of like they're random settings and random values, but I assure you they're very carefully calibrated. It took a while to get settings that looked correct to all LODs. So here they are. So body, and the ordering of the custom LOD mappings, I do not believe matters at all. It's just the ordering of up here that matters. So for the custom LOD mapping for body, it is 111, 222, 33. For the legs, the legs aren't currently being used, so I currently have these as default values, but if you were to add a mesh onto the legs, for example, you might just want to copy the values, say, of the torso. That's for the rest of the outfit at the moment. So let's see. So for the legs, they're just default values of 0, 0, 1, 1, 2, 2, 3, 3. But again, I'm not using those. But if there were, I would probably adjust them to match the torso. Feet. The feet, we didn't want the shoes, if we go down to the wireframe view here, we didn't really want the shoes to get too carried away in terms of performance cost, since they're so far away from the camera. So I've just kind of made everything kind of topologically even here. Probably the highest poly count there is actually the body, which is the foot you can see has the most polygons there. But at the moment, the shoes are good enough quality even at the lowest LOD level, which is, I've set it to 2. I thought that looked good enough to keep even with the quality of the clothes when the camera is going to be this high anyways. So I've gone ahead and bumped that all the way up to 2 to reduce the poly count there. So the feet will start off at 2, and they are 2, 2, 2, and then the rest is 3s. So 3, 3, 3, 3, 3. Okay, so that's the shoes, or as it's called, the feet. The torso, is the clothes at the moment. So as a lot of people like to configure it that way, the torso is 0, 0, 0, 1, 2, 3, 3, 3. So these are the values that are the most important of all, and they try to drive everything else to these same values unless they override them to a higher value. So here, for example, at the closest distance, the torso will attempt to drive the feet to 0, because it says 0 here, and the feet will intercept that and go, wait, which is greater, 0 or 2? And the answer is 2, so it will say, oh, okay, we're going to actually display 2 and not 0. So that's kind of how that works. And the last one is the face. The face, if you take a look again at the wireframe mode, you see it's a little higher polygon than the clothes, etc. I thought that was worth the cost, especially as there's animation playing in the face. You could even drop that down to LOD 2 if you wanted. But I started off at the moment at 3, looked basically the same as 2. I think the most expensive thing on the face is actually maybe material cost. But facial animation sometimes can be a little bit costly too, as you'll see with in-world AI. When the character speaks, sometimes the frame rate drops. So anyways, this one is starting off at 3, so 3, 3, 3, and then 4, 4, 6, and then 7, 7. Okay, and so the face actually has 8 different LODs, where everything else has 4 LODs. And they do mention this in the online documentation, and the way that works is so like if the torso, for example, attempts to drive something here to 3, then I believe on the face it attempts to drive, since that's the last LOD, so that's like the 4th LOD level, it attempts to drive it to 7 or 8, something like that. I think at this distance it'll try to drive it to 7, and this one will try to drive it to 8, I believe. But I'm not 100% certain on that. But what it does do, this LODSync component, is understood to convert from everything on the body being 4 LOD levels to the face being 8. It knows the face has 8, so it does do a doubling or a conversion from 4 to 8 specifically for the face. So do keep that in mind, as everything else here will go from 0 to 3, except for the face. This one is actually going to be going from 0 all the way to 7. I'm not driving it all the way down to 0. I'm actually starting it off at 3. That has no relevance to this 3 up here. It's completely unrelated. We could easily put this at 0. So this goes from 0 to 7. Everything else goes from 0 to 3. So that's just how they will map. The face is a little bit funny like that. Again, I'm not sure how much of this is actually detailed in the comments here. Uh, Unfortunately, not very much. Yeah, I don't think it makes any mention, in fact, of that at all here. So this is a tricky component to get a handle of how to use this LODSync component. It's very, very poorly documented. Um, okay, so let's take a look at the last settings you want to set, and that is the body. These kind of match up with the lowest level of detail that we had in the LODSync component for each of these. So the body, if we go down to level of detail, advanced, I have forced LED model to -1 just so that it automatically switches. You might be able to set that to 0. There's no comment here, so I am not 100% certain if you need to set that explicitly to -1 or not. But importantly, you want to set MinLOD model to 1 and checkmark this override MinLOD. That's not checkmarked by default. So you can tell that over here because you can reset these to the default values. So these three have been edited. For the face, very similar. Also -1. This time it's going to be the MinLOD is going to be 3. And also you want to checkmark override MinLOD. And that's going to enforce that this 3 is the value that's used rather than the value that's built into the head mesh if we were to double click on this face mesh. There's also a value we can edit there. But that's what this checkmark is for, is to ensure we use the value that's here rather than the value that is there. Okay, let's see, 3 more. For the feet, we have set the same thing as before, except this time the MinLOD is 2, and that also matches up with LODSync component for the feet, which starts off at 2. And just like the body starts off as 1, we set it to MinLOD level of 1. Just like the face starts off at 3, we set the MinLOD level of that to 3. Torso, MinLOD is 0, and we're not needing to override this really. These are default values because we actually do want to go all the way down to 0. And that is reflected as well in the LODSync. Whereas in the torso, we do need to be able to go all the way down to 0. And then the legs, which we're not using at the moment, are just default values, but feel free to customize those to match whatever is the lowest value displayed in your legs section. So in that case, we'd want it to be 0 here as well, unless we customized it to match some other component. So anyways, that is in a nutshell how they work. Let's dive into just one of these real quick, such as the torso. We're going to the mesh here. So in the mesh of clothing items, we have a LODSettings value that we can set. And so if we open this drop down, there's 3 LODSettings data assets in the project. One for the face, one for all the different clothing elements, and one for the body of the character itself. So if we were to double click on this for the clothing, so there's a shirt, pants, shoes, hat. Each of these has 4 LOD levels. So you can see index 0, 1, 2, 3. So there's 4 of them. 0 being the lowest, in other words, the highest quality, for some reason is the lowest number. If we were to go, say, to LOD1, for example, we kick that in starting at a screen size of 0.4. And what that means is that if we were to go into the mesh here, we look here at the top left, it says current screen size 1.027. If we were to zoom in, you can see that value get larger. If we zoom out, that value gets smaller. So when we get to 0.4, you'll notice that our LOD 0 will kick to LOD 1 as soon as this value hits the 0.4. And there it just did, kicked down to LOD 1, or kicked up, I guess, to LOD 1. And then we zoomed in a little bit, and that value went past that threshold, and it dropped again back down to LOD 0. So the further we get away, the higher that LOD goes, and therefore the lower quality of a mesh we will get. We'll be dropping those polygon counts as we get further away. So 0 is the highest quality, and so you can see in 1, we've got that starts at 0.4 screen size. I wanted to make sure it dropped back into LOD 0 the moment we got larger or closer to the model than that, so I've set that to 0.41 screen size. Make sure that that was a sharp transition. So here in the reduction settings of LOD1, we have the percent of vertices. This is how many, vertices, how much we want to reduce the model by. So you'll notice that that's also set to 0.4. That's purely coincidence, has nothing to do with the screen size. And so what that means is that when we go from LOD0 to LOD1, the triangle count goes from 17,000 down to about 6,000. So that's about 40% of the or if we look at the vertices here, they go from about 10,000 vertices down to about 4,000 vertices. So it's about 40% of the vertex count. So, and that's how each of these works. There is one value that if you're getting that you will often have big problems with if it's not set to 0, and that's this LOD hysteresis value. And if you I noticed on the body mesh, for example, it was set to 0.5 at one of these LODs, and that's a big mistake. And maybe it was just set by mistake to that. But what resulted was several days of frustration and confusion as we moved around on device with the VR headset distance-wise and expected once you got to a certain distance it to pop to a different LOD, and then once you came back through that threshold, it to return to the previous LOD level. And that would not happen if this where'd it go? This LOD hysteresis value was not set to 0. It was set to like 0.5. And so what happened is that kind of causes it to get stuck at an LOD value that it shouldn't be as you're transitioning from one distance to another. And so if that value is greater than 0, like if it's say 0.5, you can get kind of stuck at that LOD level way further than you should, way longer than you should as you're trying to go to other LOD levels by walking further or closer to the character. And it will just kind of get stuck there. And they designed this so that you could put this at a nice reasonable value like 0.02 or maybe 0.1. And this way it just kind of helps prevent that issue in game where you, lean forward and backwards just a little bit and it keeps popping in and out of a particular LOD level and creating that artifacting. So that's why they created it, is to prevent that from happening. But certainly throughout the course of development, you'll want to leave that at 0. And then I'd only experiment with that towards the very end of development when you're ready to go. If you want to risk putting that at like 0.02 or 0.1, that's about as high as I would risk going with that. Okay, so yeah, each of these has 4. Each of the clothing meshes will borrow these 4 LOD settings from here. And as you can see, screen size keeps getting smaller. Screen size for the third LOD, LOD2 is 0.25. Screen size for the next one, the furthest one, kicks in at 0.125. And as we zoom out, you will see it kick into those LODs at those appropriate screen sizes. So yeah, they're just kicked into the final one at 0.12. Yeah. Okay, and the only thing that's different is that the face mesh will have, for its setting that it's being driven by, it will have 8 of these LODs instead of 4. So if we were to open it up, you can see that there's 8 here. They work very similarly. Again, for the face, we are starting off at LOD3. These others, if we were to go all the way to an LOD0, I think you would see that they have very high poly count, so we can just see what it is. Oh, it looks like it won't even allow me to go to LOD0 because I have forced it, but I think it's like 64,000 polygon counts for LOD0, so something very high for the face or for the body. So, okay, there's one other thing I wanted to mention about these values here. And I think it was that when you import a new outfit, what you'll want to do is adjust. So you'll open up the mesh. So this is the mesh, the clothing mesh that we're using for the torso. And when you first import a new asset, it'll probably say number of LODs 1. And you'll want to adjust that to 4, because everything except the face has 4 LODs. And then you'll want to hit, importantly, this drop down here and select Metahuman Clothing, and then you'll importantly want to finally hit Regenerate. And anytime you make an edit to this Metahuman Clothing LOD settings, it will affect all the clothes on all of the characters. It's a nice, easy way to bulk edit the distances at which different LODs pop in and out. But every time you make changes to it, you want to go through all the characters and hit regenerate on this, especially if you're messing with polygon counts, with this adjusting this percent of triangles, for example. Very important to go through and hit regenerate on all these different meshes. Okay, so I think that was the last important thing to mention. Let's see, anything else? Yeah, so okay, so I guess the eyebrows are kind of expensive, so I decided to do away with the eyebrows and just go with a painted version of the eyebrows. Some of the characters, the eyebrow mesh was working, and some it was not. But I went ahead and went through and noticed that for some reason the texture on Wayland in particular had no eyebrows at any LOD level. So you may, if you have another character that happens to, you may need to go into their blueprint, go into their face mesh. Here it is. Go into the material slots here and take a look at anything that is a head synthesized underscore baked material, and just double click those one by one and make sure each of those has some eyebrow texture on it. And so there's a couple ways to do that. One is you can adjust these two maps here to find the version of it that has an underscore LOD, because the underscore LOD one version of this map has that texture kind of baked into it. The other way you can do it is you can go down to this color underscore main and replace that. It'll initially be face color underscore main, but you can change that to face color underscore main underscore LOD, and that's the version of the texture that actually has the eyebrows painted and baked in. So that's what you're seeing here. If we were to change this back to the texture that read face color underscore main, you'd get rid of the eyebrow texture, and because we're not using grooms on mobile, we're not going to use those expensive eyebrow cards. Wayland would be without eyebrows on Oculus Quest. So that is something to note. The characters, interestingly enough, can handle rendering eyelash cards, but the eyebrow cards are a little too much. So the eyelash cards seemed more important than the eyebrow cards for which a texture could suffice. So we're able to hit acceptable frame rates, I think, for App Store deployment with the eyelashes working, and with the eyelashes and the eyebrows, I mean baked and disabled, baked into just textures and disabled. I think it's good enough. If you have to kill the eyelashes, you can. I think they look really good. I'm really pleased that you can actually render it at good frame rate and still have those eyelashes in at the moment. They make a huge difference for characters like the conductor. Just looks totally different without his eyelashes on there. But another option is you could go into Blender and you can create a custom baked out eyelash card that's very, very simple and minimal compared to this really very, very high poly eyelash card set of eyelash cards they've got here. That would take a lot of work, but it's an option you could explore as well. Anyways, so I think I will end it there. And why don't we take a look next at how this runs on device? Let's take a look next at the Oculus Quest 2.
Okay, so now we are on Oculus Quest 2, as you can see here from the controllers. And we're just going to try to launch into the app. Sometimes you have to do this 3 to 6 times to get it to run on that first attempt. Sometimes it works on the first try. That is a common issue with Unreal Engine developer packaged apps. So if we take a look here at the conductor, you can see he's now at his highest LOD levels. You can see he's got eyelashes, and they're showing up pretty well even on the Quest 2 here. frame rate's above 70 at the moment, which is pretty great, given the fact that we're recording and in-world AI is also running. Let's see. If we hit the Y button on your left controller, we can actually toggle clothing on and off. And you can see that seam there at the head and neck. Though there is a color kind of texture change there, there is no geometry issues here with this seam. It looks perfect. And that's because the body and the head are in compatible LOD states at the moment. And as we get further away, they also remain. So for example, if we look at the characters at a distance that are much worse LOD levels at the moment, they also do not have any holes in the mesh or visible seams at that shoulder neck seam area. So now, interestingly, because the clothes are what is currently driving the LODs across each of the characters, we can actually take a look at what those lower, or those worse, I should say, higher LODs, worse LODs look like as we get closer. Because the clothes are not visible right now, as you can see, they're not actually driving any of the other components' LODs. Now, if I were to turn the clothes back on, you will notice that the head and the hands and everything will snap to the correct LOD levels. So that's why it's important for whatever is driving the LODs of the character to always be toggled to the visible state at all times. And you can see Wayland also has eyelashes if you get close to him. You'll notice it's kind of funny, he keeps his mouth open while he's listening to what I'm saying here. Sometimes that happens with in-world. You'll notice that the eyebrows are fully painted on here. You can see there's definitely no eyebrow cards. As I clip through it, you can kind of see them. It's just texture. But the eyelashes, you can see those coming into visibility as we clip through them with the camera here. So you can tell the eyelashes are real geometry, but the eyebrows are definitely not. Those are just texture. And that's the way it is for all of these characters. You can see again as we get close, there's no seams there. Let's take a look at the LOD level here. Here's kind of an intermediate LOD level he was rendering at that we teleported up on. If we were to toggle his clothes back on, the correct LODs are immediately adopted. We turn them back off, and now it's a little bit higher quality again. So yeah, you can see the conductor, same thing. If we switch to clothes, excuse me, switch the clothes off, and we travel over to the conductor, we can see what he looks like, the level of quality that he's rendering at when he's being rendered from such a distance. So we're saving on performance by doing that. So, okay. I think that about wraps it up. If you're interested about the environment itself, it's just something I kit bashed together in Unreal Engine with the modeling tools there, except for the chairs and the curtains. The curtains came from another Unreal Sample project. I don't believe you need to credit those. I'm not sure if you can use them in games or not. The chairs, I believe, came from Turbo Squid, if not mistaken, or the Unreal Engine Unreal Marketplace. I've included the credit you have to include in the credit section of your game if you do want to use it. Otherwise, it's totally commercial free, but it does require crediting the artist who created this chair in the credit section of your game if you do want to use that. They're not the most optimized. I did strip tons of textures off of this, but still, if you wanted to improve frame rate even more, I mean, we're on Oculus Quest 2 and we're hitting 72 frames a second right now with all this geometry with these curtains here and characters in the scene in the distance, still pretty close to 70 frames a second. So that's pretty good, but I think these could still be optimized a little bit more. The curtains are probably about as optimized as you can get, all static lighting. Yeah, these doors are just carved from sculpting tools inside Unreal. And everything is baked inside Unreal, totally static lighting using their light mapping baking solution. So if you go to the project and you just do build and then build lighting, it should rebuild all of this. You go to the world lighting settings, you can kind of see how everything's configured. And again, this is the L_train level that you can look at all those configurations. So anyways, hopefully this provides a decent starting point for seeing how you could achieve 72 frames a second, even on Oculus Quest 2, which is now getting a little bit older, but according to Gorilla Tag, still has by far the most users. Oculus Quest 3 is not caught on yet. So, alrighty. Well, I will end it there, and let's jump on over next to the Oculus Quest 3. Okay, so now we're on the Oculus Quest 3, and we'll launch into the app. I put a little splash screen for you guys you can customize. So the main difference is that the frame rate is just a lot better on the Quest 3 than it is on the Quest 2. I think it's about a 50% performance improvement. Let's see if we can get close to Wayland's eyes here to see his eyelashes. Not sure what's wrong with the floor leveling here, but kind of have to step on my tiptoes here to see his face, but the eyelashes and the face are easier to see the detail level of with this higher resolution display. So you can see the hat popping in and out of LOD levels there. I didn't talk too much about the hat, but it has its own custom LOD settings that were not being synced with the LODSync component. You can completely avoid using it if you wish.
I'm afraid I can't quite follow your
the main purpose of the LODSync component is so that you have the shirt and the face and the body all swapped to a new LOD at the same time, and that's important because remember this head seam, head, neck, shoulder seam, if the topology of the face and the topology of the body don't match just perfectly, there will be some very poor holes in the mesh right around here. So that's the main reason why you want to generally avoid syncing them individually, or just having the LOD be controlled component by component. You want to use something like LODSync. That's the main advantage, is prevent this sort of thing from happening. So, anyways, at LOD1, I think the hands and the body probably look good enough for Oculus Quest. Shoes look good enough. It's probably just a matter of whether you want to keep the eyelashes or not. Some characters, it only helps a little bit. Others, like the conductor, it makes a tremendous difference on their realism with the eyelashes with and without. So, yeah, just feel free to play around with it. If you want to visualize the FPS on device at all times, there is an app for that on the App Store I'd recommend getting. That's produced by Meta. They create it. It's called OVR Metrics Tool. You can search for it in the App Store, and then you can download it right here. When you open the app, there's settings. The main thing you want to do is checkmark, toggle on this Enable Persistent Overlay, toggle that on, toggle this to none, and then go to Stats here and scroll through until you see average FPS and toggle that one on. And once you toggle it on, I think it disappears from the right-hand list and moves over to the left. And then this frame rate will appear on your screen. And you can go back to settings and you can adjust the pitch and yaw positioning of that frame rate display. So, okay. Well, I think I will end it there.